what is their impact on grid stability, reliability, and efficiency also. So as you know that most of the time our conventional generation is very in conventional generation there is only one way flow of power, right from generator, then transmission, and then discom. But as you are knowing that more and more renewable energy sources are coming into picture, so the bidirectional power flow is also possible, and not only bidirectional power flow, with the penetration level of the inertia is also being compromised, because the inertia has stability issue. If you are losing the inertia, that means the natural inertia available inside the rotating mass, it is going to be decoupled from the system. It is not going to be there. So just like a moment, if you understand that the basic science, if you rotate if you switch on the electric supply, the time constant of electric supply is very fast, small time constant. But the fan, which is an electromechanical device, its a time constant is little bit higher. So the moment you switch on a supply, the fan is not going to respond according to that much supply. Means if you are applying 230 volt supply and it is supposed to rotate at, let us say, 1500 rpm, it is not going to instantly start at 1500 rpm. It will take some time, maybe 2-3 seconds to pick up that rated speed. So that means the time gap between the instant at which we have applied the electric supply and the time at which the fan has fully picked up the speed. So there is some time gap, and that means some amount of energy has been utilized by the fan to overcome its inertia. Similarly, when we switch off the supply, the electricity has been cut off instantly, but the fan is not going to come stand still at the same instant. It will again take some time to come to the standstill. So that means again the amount of energy which was stored inside the rotating mass, it has taken some time to damp out. So that mismatch of time constant is very important, and that is having sometimes we say it is having a stabilizing factor. So in our normal system, what is happening, like we are generating electricity, and accordingly we are having some so as we are generating electricity, we are trying to keep a match between demand and supply. If the losses are supposed to be negligible, then PG is equal to PD. So that means, or PG equal to PD plus P, demand and losses. Loss, I can say demand itself. So PG must be equal to PD at any time in order to make your voltage and frequency constant. So that is the conventional way. But in actual way, what is happening? The mismatch is happening in a routine manner, because load is always fluctuating in nature, and to match that fluctuating load, you have to keep on varying your generation. But as I have told, most of the generators are based on prime mover. The moment the electrical load is electrical in nature, but the generation is electromechanical. So there is a mismatch of time constant. And the mismatch is because the moment the electrical demand has increased or decreased, at the same time the mechanical input has not been increased or decreased in synchronous to your load. So what will happen then? Your voltage and frequency will go out of control, means out of beyond the rated limits. Just like voltage and frequency, if we are keeping a limit of 1% variation in voltage, we can keep 5%, maybe at transmission level, at distribution level it can be maybe of 10%. There are different standards also worldwide. So every country having their standards there. So according to those standards, the voltage deviation, the permissible voltage deviation is allowed only to accommodate those small kind of load fluctuations. Okay, because load is continuously fluctuating and your generation is had to be controlled according to the load. So you can say that the grid stability is one of the major issue. Power quality issues are there. Then, and you can say how to control the latest technological equipment, the equipment which are going to be utilized for harvesting renewable energy sources. How to control those devices so that we can overcome the natural problem being arise of loss of inertia. So we have to think about all those things. So motivation are these only, that how we can introduce the renewable energy sources while not compromising the loss of inertia. Similarly, microgrid, smart grid concepts, and then different. I have done some case study during my PhD also. So I am going to introduce that part also, that how the renewable energy sources can we contribute in stabilizing the grid or ensuring the reliability of the grid. So these are the some part of the system. So working of power grid, as I have already discussed, that there must be always a continuous balance between demand and supply. If there is a mismatch, the voltage frequency is going to be deviate beyond its permissible limit. So in order to make this, and in conventional system, you know that how our system is working. There is a big generating facilities. Then you are having a transmission line network. Then you are having a commercial consumption like transportation, residential building or something, and then you can have a distribution network. So this is our conventional way. The bulk energy generation, transportation and distribution. One way transmission only. But if you introduce more and more non-conventional energy sources here, so now you see that you are having a bidirectional power flow. Means the distributed generation is taking place at the consumer end itself, and the consumer is now becoming a prosumer. He is a producer as well as a consumer. Sometimes he can generate more than its requirement. So what will happen to the surplus power? Ideally it should go to a battery. The battery is a grid system. In a grid-tied system, grid itself is acting as a battery. So now the grid is having more instability now, because in previous case it had to handle only the load fluctuations, but now it has to handle not only the load fluctuations but also the generation fluctuations because of the renewables. The power coming from the renewable is no more under your control. It depends on the weather conditions. So weather conditions are not in your hand. So, but our objective is you have to utilize maximum energy out of the renewable energy sources so that you can limit your carbon footprint. The main thing is you have to reduce your carbon footprint. So, in order to reduce your carbon footprint, it is a mandate of the government and all the government all over the world. Every country working in that direction, that we have to reduce our carbon footprint. So, in order to reduce the carbon footprint, it is a mandatory requirement that you have to optimally utilize your renewable energy sources. But renewable energy sources are intermittent in nature, plus they are having inherent problem of inertia, loss of inertia. So these two critical issues are there, which are becoming a great challenge to our power system operators. So the reliability of the power system operator may be compromised if and more penetration of renewable energy is going to take place in the power system network, and you don't have any effective means to control that. So that is a major thing. So the bidirectional power flow is possible, and this is making a consumer more empowered, because earlier there was only the participation of the state electricity boards or DISCOMs, distribution companies. The consumer had to rely on their service. Whatever service they are providing, you have to accept it. But to ensure more power system reliability of your own consumption, you are installing a backup as an inverter. You are having your own DG set, or you are having also a solar power plant installed at your premises. So that means now the consumer is having more aware, and it is the consumer is having a lot of options. And in near future, you may have the system where you are having your power plant, solar generation, you are having a backup in the form of diesel generator or battery, and then you are having a rolling battery also inside your electric vehicles. So you don't need to be connected with a DISCOM also. Your electric vehicle can curtail all those power fluctuations. When most power is being generated, it can be stored inside the vehicle. And when least power in the night, there is no power generation. You can extract that power stored in the inside from the battery. So, and just for the some weather condition or some 2-3 days some storm came or nothing, something is happening, you don't have electricity. For that purpose, you can have battery backup, or maybe you have a battery backup can be only for 2 to 4 hours. Economics is very important also. So sometimes only 2 to 4 hour backup is there, but if more reliability required, then you can have a generator set as a prime concern. But it has been observed that in most of the conditions, no more than 2 to 4 hour backup is required. Now, at least in India, I am talking about NCR region, and maybe in some more advanced states where the blackout of 2 to 4 is not that much high. So even if you need to ensure, that means you have to pay for the reliability of the supply. So to ensure the reliability of supply, you must have all the provisions. Now, what is happening? Bidirectional power flow is happening, and next situation is the inherent disadvantage, which I have already discussed, that it is a weak inertia system, intermittent in nature, and you don't have control on its output power. So these challenges are there, and if we can design some advanced algorithm through which we can have a perfect mapping of load curve and generation curve, we call it a smart grid technology. In smart grid technology, we try to match the pattern of load through generation. But since now generation is no more in your control, what is in your control? Load, microscopic load control. If you are having the ability to control the load of each and every body, that known as smart grid technology. IoT enabled devices are going to be there. You are having right now, you are having 32 ampere, 15 ampere, 6 ampere plugs in home, and you know that in most of the houses, AC, dishwasher, or microwave oven, or even refrigerator, they can be a bulk energy consuming devices. But rest of the devices like electronic appliance, fan, lighting, and charging purpose, these are very small home appliances which can work only some 20 to 60 or 40 watt only. But most of the power, which bulk power at domestic level, is consumed by the air conditioner and dishwasher and all those things. So you are having the priority, deferrable and non-deferrable load. You can defer your washing schedule, you can defer your air conditioner also sometimes, because electricity for essential service may be required, and then accordingly you can design your priorities also. So load priority can also be defined based on your requirement. Load deferral algorithm can be designed for based on your energy requirement. So smart devices are there which are continuously having access to your energy consumption pattern. They are having access to the energy stored inside the system, and the real-time power being generated. Depending on them, they are having some optimal algorithm through which they are continuously switching on or switching off your load. Okay. All these things are happening. So IoT is required, machine learning approach is required, and advanced power electron skills are also required in order to implement all the things. So I am saying now no research problem is in isolation. It cannot be a typical power system problem, it cannot be a typical power electron system, it cannot be a typical AI/ML system. All these problems are integrated, and one must have to work as a team in order to meet all those kind of skill requirements. So coming to the working of power grid, as we already know that that thing I have already discussed. So harvesting, our motive is to harvest maximum renewable energy, and at the same time we have to limit our consumption through conventional generation, and while minimizing the losses also, because distribution generation has unique you can say advantage, that the transmission line losses are going to be reduced if you are generating the power at the consumer itself, at the consumer end itself. Then no more additional of transmission line network, plus no more transmission losses, no expansion of transmission line network also. So that is also one of the advantage. But unfortunately, in a country like India, where the hydropower potential is somewhere situated from the faraway load center, similarly renewable power generation like from solar and wind, it is also generating from different locations, but they are maybe away from the low bulk consuming load centers. So the power consumption may not take place at the same location where the maximum load consumption is there. So definitely we have to look for some cheap locations where electricity, where solar radiations or airflow, sufficient airflow is available throughout the year. We are generating over there, and then we are transferring it to the system. So distribution generation is no more a typical distribution generation. It is again now becoming a conventional generation, where the plants of wind turbine and solar power plant in the terms of 3 gigawatt, 3000 megawatt capacity are coming up. These are acting just like a typical conventional generating stations, and then they are the power from them these locations is being transferred to the that load centers through transmission line network only. So the distribution generation not a truly now a distribution generation if we are generating a like conventional system. Although it's a different story if you are generating electricity at your rooftop, that is a different, but that percentage is very small in comparison to the gigawatt size solar power plant. So that is the solar wind, or maybe even in a day micro hydro is also coming in that category, renewable energy category. Maybe in future tidal energy is also going to be harvested, so it is also situated away from the bulk load centers. So to have to evacuate those power, the power being generated at those faraway centers is again a big problem, because of the typical problem of current effect. Under light load conditions, the receiving end voltage is higher than the sending end voltage. But what will happen if you are generating more at the receiving end? Then the voltage again going to shoot up. So the issue is arising that the solar power developers or wind power developers, they have to install big reactors to absorb that capacitive reactive power. So that is also becoming a challenge. Evacuating power from gigawatts size wind turbine or solar power plant is not that much easy, because they are being generated at light load centers, and the current effect voltage is already high, and you are further generating at that point. So again it is going to be very high. So evacuating power at point of common coupling is a big issue, and to keep the voltage within the permission limit at point of common coupling, we call it PCC, you have to have dedicated reactive power. This was the case when I was doing my PhD. I visited that one wind farm at Kansas Wind Farm, USA. They were having 300 megawatt installed power capacity, but hardly they were able to supply 20% of their nameplate capacity because of that power only. Because in North America, including Canada, I say North US, North America, US and Canada. So in North American side, the centers, they are spread and there is no population, nothing is there. More and more first generation wind turbines, self-excited induction generator was installed over there, and they were consuming a lot of reactive power in comparison to whatever active power they were supplying. So they were having more lossy impact on the system rather than producing some fruitful active power. So that kind of situation was there, and then we were working on some project given by Vestas and ABB, and at that time I developed a concept where the power electronic capability of grid interfacing inverter can be utilized to generate the sufficient reactive power. Because for reactive power generation at that plant PCC, they were installing that reactor. So what we did? No, you can calculate the amount of reactive power to be supplied, and most of the, since 20% of the capacity was only utilized, 80% was already available, or you can say 100 square minus 20 square, and then it is going to more than 80%. So that much reactive power support was already available in terms of grid tied inverters. So we suggested that instead of having a dedicated additional bulky reactor, or seed thyristor or something like the thyristor seed reactor, we must have to utilize the installed reactive power through the grid type converter only. So what we did, we calculated the amount of reactive power which a device can give in proportion to its rating only. But grid can have sufficient amount of reactive power demand, but as a small appliance, you cannot sort out all problem. But what you can do, you can give the amount of reactive power support in proportion to your capacity. So if such number of n number of devices are there, and if they are going to be controlled in such a way, then the issue of reactive power can be easily sorted out by these kind of devices. So that's why the concept of LVRT came into picture, low voltage ride through capability. Earlier, the solar power plant or wind power plant was supposed to cut off whenever there was some fault on the grid side. What is fault? Voltage fluctuation, frequency fluctuation, more swing in the reactive power demand. So those were the only faulty conditions. So under those conditions, most of the renewable power developer or RESCO company, renewable energy source company, they were supposed to cut themselves from the system. So that was more destabilizing impact on the grid. Already it was in trouble, and further you are disconnecting yourself. So instead of supporting the grid, you are again destabilizing it. So what was the concept that instead of disconnecting yourself during the faulty condition, you must be connected and you must keep on providing the amount of reactive power, whatever capacity are available, and sometimes at the cost of curtailing your reactive power generation. You have to curtail your reactive power and you have to keep on ramping up the reactive power. So that means there are simple two components, ID and IQ. Voltage got by the voltage at the point of common coupling. So only thing is the amount of current which you have to inject, which comes in the form of ID or IQ. ID and IQ is always in your hand. You know the kVA rating or MVA rating of the inverter. You know the voltage level of the inverter through point of common coupling. So as an engineer, you can very small calculation. You have to calculate the real amount of active and current only, and you can divide the current into further into its active and reactive component. I hope all of you are able to follow this. The concept which I am discussing, you can always calculate the amount of current, and the amount of current which you have calculated, it can be further divided into say active and reactive component depending on the requirement. And similarly, not only this, I also introduced a concept where the non-linear load compensation at the point of common coupling, it can also be compensated. And this was my first paper which was published in 2009 only, IEEE power electron and power delivery also. And at that concept, after it was given as a smart inverter concept, and I was awarded best paper award in IEEE Orlando, Florida, IEEE electronics conference also. And after that, it has become a standard. Now people are exploring it through I have given universal control. So that kind of control was always, so we have not only given the active power support, not only the reactive power support, but also the harmonic compensation. And that kind of capability can also be utilized in bidirectional charger of EV also. Where if you are having the power electron device, you are having the capability to control or manipulate the amount of current to be injected, you can do the wonders. It is simply a case of understanding the process. If you understand any process, you can easily manipulate it according to your requirement. So this has given to a concept, new concept which is known as smart grid technology, where the generation load is being followed by the generation. You have a load assessment, and according to you are scheduling the generation, and that is happening. But nowadays, generation is variable in nature. So now you have to change your load according to the generation. So that is a concept of smart grid, where the load is to be followed by the generation. In previous generation, Previous load is to be followed by the generation, but now generation is to be followed by the load. You have to keep on changing the load according to the generation, so that you can have perfect match between demand and supply, and you can keep the on balance the volt and frequency. So these are the some studies which have been already well established, that the voltage that wind and solar are complement to each other, and so during the night time wind is generation is very high, during the daytime solar is generation very high. So some amount of fluctuation can be overcome by themselves, and slight mismatch during the evening or morning hour, so that you can have a sufficient backup of battery energy storage system. And nowadays every government is coming out to have the SPD, solar power developer or wind power developer. They are supposed to install gigawatt size storage also, up to 20 to 30% capacity of their generation capacity. The concept is there, 1.6 hour to 4 hour. Why? They have to store in a battery energy storage device. Now integrated projects are coming where with the solar power plant you have to also having a battery energy storage capability also. So 20 to 30% capacity. Standards are coming, they are not very precisely, but I know in advance that 1.6 hour is the minimum standard which NREL has decided, US, and it can go up to 4 hours in Indian context. So let us say 1 kilowatt generate 5 units. 1 kilowatt in a day generates 5 units. So 20% come out to 1 unit. So for 1 kilowatt solar power plant you have to have a 1 kilowatt hour battery backup. If you are going to 40%, 2 kilowatt hour, and so on. Because 5 kilowatt is the standard output coming from a solar plant on a given location in India at least. Because 300 sunny days are expected, and roughly 1400 to 1400 to 1500 units are going to generate on per kilowatt basis. So accordingly you can decide. So 1 gigawatt size plant, accordingly you can calculate the amount of battery backup required. So these are the standards coming into picture, because now the battery are going to give you a virtual synchronous inertia or synthetic inertia. Well, inside the rotating mass, what is there? Kinetic energy. If sudden load has been suddenly increased, the speed of the generator will slightly decrease by, it will decrease that amount, because half j omega square. That is the energy. So if initial operating speed is omega 1 and the speed has been reduced to omega 2, so half j omega 1 square minus omega 2 square. That difference, omega 1 minus omega 2 square, that amount of energy is already available inside the rotating mass in the form of inertia. J is the inertia constant. But unfortunately, because we are going to introduce more and more renewable energy sources, that half j omega square capacity is not available. So to overcome that issue, we are going to have dedicated battery energy storage systems. We call it utility scale energy storage system, megawatt, gigawatt energy storage system. And those facilities have been already installed in Australia, and in US also, in China also, and India is also tendered at certain locations to go for that kind of thing. If some of you are from power sector, I don't know how many of you are from industrial background, so you might be aware of that.
Concept. However, I don't know the English transmission distribution also in future. That is going to come. Okay. But load scenario, the power density, usage of the power electronics is going to increase. So now the switching also, we are going to be very fast switching.
Yes.
Switching technology is going to increase, so power quality is going to disturb very well.
Exactly.
Right now also, one side we are planning, okay, have a EV, charging battery, but until unless you don't have dedicated feeder for that, because characteristic is the importance. to deal with the characteristic, not to have an adverse effects on my assets. Okay, then reliability come into the picture. Okay, so now characteristic, without understanding the characteristic of at the load where it is being generated, okay, then we are putting all this in haphazard manner, plugging the things. So reliability flavor is, on ground.
Okay.
We are missing a lot, and management also. So now, what I mean to say, all the stakeholder, start from blueprint is the academician, okay, and other regulatory and standard maker. Now see that today a standard, okay, for the power quality. A standard you have, I think, the 63 order of dealing of the those thing, and but today you have a switching in a band of the start from the 9 kilohertz to the 100. That means the order come more than the 100 and something like that. Okay, we don't have the standard.
Sir, standard.
So all the stakeholder has to be on the same page. Let us understand, visualize the scenario, what is coming ahead of us, and you have to prepare. Otherwise, we are going here and there. See, in a dark side of the LED light, without understanding those, they have put the LED light.
Sir, now I am coming to your question also. Now the term which is known as custom power devices. Custom power devices, they are also known as active power filters, STATCOMs, D-STATCOMs at distribution level, DVR, thyristor wave effect devices. I don't know from which background you are, but I am talking about if you are going to have more and more interface of power electron devices, then power electricity is the only solution to curtail those kind of situation. Poison is only for the poison. So the transients which are being introduced by some kind of load, the anti-transient can be introduced by the similar kind of devices. So that concept which I am going to make you aware in the upcoming slides, I have given that solution. If you stay interested, I will show you that. The power electronics, it is just like it can be utilized in both ways. On the one side, it is generating, it is creating pollution, as the sir has rightly said, pointed out, that all the power electron devices, the ILED and all these things are going to create lot of trouble. And the clear-cut example is, if you go to a DMRC metro train, if you ride a metro train, sometimes if you jerk, lot of 13th, 65th, 90th order harmonics are going to generate by that particular device, and at the point of we call it SP, section and parallel unit section, SSP, parallel section and subsectioning. So at that point, they are going to install a dedicated filtering device in order to meet out those fluctuations. Otherwise, the harmonics are going to play with your normal supply, and those kind of fluctuations or transients affect are dominating on the electric drive also. So those things are there, but solution is also coming. So coming to that part, so they are naturally, you can say they are complementing to each other. So 2 to 4 hour backup coming in a days where the renewable power developer have to come up with their own energy storage also. So that is the thing. So now coming to the power quality which you were talking about, since it is having lot of issues, you can have amplitude deviation typically, then you can have certain other issues which are coming from the deviation because of the swell, sags and spikes, all these things which you are discussing, all these are integral part of power quality. So disturbance in power system network and deviation frequency, deviation in harmonic content, all these are the particular part of, so these are the power quality events. These are the transient, you can say, impulsive transient, which is coming because of the switching of the power electron device. Similarly, you can have sustained oscillations also for small duration, that is also coming into that category also, and all power conditions. Then you are certain having a voltage sag also because of the swing. In reactive power, you can have swell also. So all these are the typical power problems. Volt unbalance. Sometimes some phase is having momentary zero also. So all these are typical power electron problems which we are discussing, and then voltage flickers, because as if you are not having properly designed a filter for your power electron device, you see most of the students who are working on power electron equipment, you might have observed the thickness of the waveform. The moment you switch on the transistor or IGBT, you see lot of flicker, and you switch off it, the waveform becomes very smooth, thin. So those flickers are also coming because of the power system. Then you are having interharmonic problem, not only harmonic, interharmonic. Harmonic means integer multiple, and those which are fractional multiple of fundamental, they are known as interharmonics. So interharmonics are also coming into picture. So harmonics, interharmonic may be more dangerous than the harmonic, because it is very easy to design the passive filter for harmonic. But how you are going to design it for a fractional frequency? So that is also one of the issues. So only the power electron can play as a device which can reduce those kind of issues which have been created itself as another power electron device. So just like लोहे को लोहा काटता है, same situation going to arise here also. उसे पानी की बोतल मंगाना जरा.
Solution. Technology have to both sides. One side creating, they have a solution antidote. So one solution. Next is the coming from the cost benefit analysis, optimization. Now these are the device in a network where you are putting that this device to the compensation. Either it will be upstream or downstream. They are dependent. So now, see the population, network and all the things, So now too many devices required. Okay?
Yes.
Because they start from branch, travel, come to the sub, then again come feeder, then going to...
No, sir. I'm just going to stop over here. You see, in industry, where the sanction load is more than 1 megawatt, there are already norms that they should not inject that much amount of
high pressure. So
Norms are there. You are not supposed to inject reactive power, demand reactive power and harmonic also within permission. Those kind of permissions are or regulations are going to come very soon at distribution level, but not at individual household level, at the distribution level only. With the in close proximity to your transformer, or the distribution transformer, you are going to install another custom power device which is going to take care of the, because load pattern, study of load pattern is very much important, and a load pattern can be very easily, because nowadays, that's why I am talking about IoT. These devices are going to play very crucial role, real time in form of the current profile, daytime, morning, evening, or during the peak power, less peak power. All these devices, the categories have been means 24 hours can be categorized into various slots. According to those slots, different kinds of load patterns are there, and according to load patterns, you can design some optimized algorithm, and on which I have already guided a PhD also. If you are more interested, you can go from IEEE sustainable energy transactions. There is one publication on that only, how to customize your load profile and all that. I will discuss all these issues, but yes, right, that power electron device are creating problem. Our system is going through a transition phase, and maybe in future, every problem is going to have some solution. The problem is not going to always sustained. So the things are coming in a big way, and that's why we are running this course. Why this FDP?
I worry in the one that all the stakeholders, they are not the same page as far as the Indian context.
Indian context.
Regulatory is also very important. Act is also very important. Standard is important. Regulatory is important. Academic is important, and ultimate user. And in between consultants.
So that I leave it to policymakers. As a technocrat, I can only discuss the whatever things are available and whatever control we are having within our own capability. Policy making, regulatory, and then business model also. Business is one important factor. Almost every technology is driven by the business. If the technology lucrative, it can be promoted to any extent, any proportion. If it is not lucrative, nobody is going to buy it. Now they buy solar, and because the cost of generating electricity from solar coming out to be 2.4 rupees. And you compare with the thermal and any kind of solution, it is more than 3.5 or 4 rupees. So it is all a business model. In totality, the problem is very complex one. It is not a one-way solution, but we are here just to discuss what is going on, what is the possibility, and what are the side effects and how they can be mitigated. So anyway, so these are the some issues which we were discussing. So you are having that thing also. So partial solutions already people are having in market, like series capacitors, series inductors, or at generation level, distribution level, transmission level only. So these are already installed. Then you are having static VR compensator, where they are utilized to give the support, reactive power support. But unfortunately, the amount of current, either capacitive or inductive, it is decreasing and becoming zero as you move away from the per unit value. Means more the deviation, the utilizing capacity of your device SVC is going to be reduced drastically. So it is very effective when the deviation is small. It is least effective when the deviation is very high. So that is it's a drawback. You see that map, you can understand the meaning of that triangle. Where that the effectiveness, the amount of capacitive or inductive current can be injected up to that much amplitude at unity value, but at per unit value. But if you move away 0.9, 0.8, 0.6, and 0, at 0 voltage you cannot inject any inductive current or capacitive current. So these SPC are not a solution, because bigger the voltage fluctuation, lesser is the capacity of your installed device. Similarly, at a silicon condenser, nowadays, because I am also expert of Power Grid Corporation of India, so I discussed that whole thing with them, and I delivered that special lecture to them also. And now the Ministry of Power is coming out with a solution that those power plants, thermal power plants, which are on the verge of retiring, they are already covered 25 to 35 years of their lifespan. The machine installed or the generation installed over there, they can be utilized as a synchronous condenser by utilizing by removing its shaft. Only the condenser, it can be utilized as a condenser, only the synchronous generator and some excitation. So depending on leading and lagging excitation, you can keep on regulating the amount of reactive power to be injected into the system. So these are the some components you can just study.
This is cost effective.
Costing is a big issue. I will tell you. That's why they are saying retrofitting. They are going to utilize only those devices which are old. The lifespan of the whole power plant has been gone. Only the machine, by having certain maintenance, you can utilize for synchronous condenser. So cost effectiveness is issue. That's why they are going for retrofitting only. It is under plan. And but it has best response time within few milliseconds, because in a natural inertia is already available, and that can be utilized for that. बताइए मैडम कितने? अच्छा अच्छा अच्छा, नहीं मैं तो 2 घंटे बोल सकता हूँ. इट डिपेंड्स कि भाई आपको लैब में जाना है कि लेक्चर सुनना है. हाँ नहीं, मेरे पास दोनों ऑप्शन है। मैं ये सब्जेक्ट इतना प्यार करता हूं कि आई कैन स्पीक ओवर डेली बेसिस आल्सो। तो इट डिपेंड्स ऑन योर एब्जॉर्प्शन एबिलिटी कि हाउ मच यू कैन एब्जॉर्ब। इफ यू विश हाँ सर, बट उसका एक्साइटेशन कंट्रोल है ना हमारे पास। हाँ हाँ वो खत्म हो जाएगा, खाली जो मशीन का वो खाली वही यूज होगा।
कम हो जाएगा।
हाँ डायनामिकली एब्जॉर्ब, डायनामिक कंडीशन के लिए खाली। यस यस जनरेटर रह जाएगा सर। सर वो रफली जो है, अगर जनरेटर डिकपल करेगा तो हार्डली उसका जो है तो रोटरलेस सिस्टम में 2% में रहता है। हाँ तो उसमें काइनेटिक वो अवेलेबल नहीं है, काइनेटिक खाली एक्टिव रिएक्टिव पावर 2% ही सफिशिएंट एनर्जी अगर देना है। हाँ बिल्कुल। Under dynamic condition, because it has no extended rotor, it's a rotorless system. So now coming to StatCom. So StatCom has the option, you know the limitation of previous customers like that. Their composition capability was going to compromise when you are moving away from the point value. But here the amount of active current or reactive current to be injected is almost constant irrespective of the deviation in voltage. So that's why the StatComs are more powerful. Further, if they are integrated with mechanically switched capacitors or mechanically switched reactors, means hybrid system. So certain level harmonics can be compensated by the StatCom and certain level can be compensated by the not only harmonic but reactive power also. They can be compensated by the hybrid system to reduce the cost of power electronics. So hybrid systems are coming. So that curve can be further modified by mechanically switched capacitor or mechanically switched inductor or reactor. So that's why the StatCom device, custom power devices having a hybrid impact can be more advantageous and they can be much better option for reducing those kind of issues. So why the you can say that what is the role of type converters? How it can improve or how it can inculcate all those properties which we were discussing right now or in previous slides. That this grid tied inverter, it can be regulated as per the optimization control algorithm. Real time calculation of the means it can understand what is going on at the point of common coupling, what is the grid health, what is the amount of energy I am generating, and according to those systems, if I can calculate by smart or IoT enabled device or smart grid technology, if I can calculate the amount of or the way of controlling the grid tied inverter, I can always sort out those challenges. So that is the problem that you are having means solar, you are having wind, you are having DC-DC converter, AC-DC converter, then again you are having a DC to AC inverter. So this is the system which is supposed to be controlled effectively. So that is the situation. So you see, so that's the concept which I have given, that smart grid tied inverter concept and its optimum utilization. So what we did, that it can do, this is the grid, this is a generator and this is a non-linear load. So that was the initial concept which we have given irrespective of the nature of the renewable energy sources. It can be solar, it can be wind, it can be battery energy storage device, it can be for diesel set also, it can be micro turbine, it can be anything. But how I am going to inject that power, that can be controlled by the power electric device only. So if I know the grid condition, if I know the load condition at the point of common coupling, I can keep on mind the non-linear or reactive power demand divided by from that. So if I can at least compromise or I can compensate the non-linear load demand of the load at PCC and its harmonic reactive power demand, some amount of active power demand, then only the exchange of active power will take place with the grid. So if the grid is controlled to be utilized at a unit factor, that is a win-win situation. So the point which you are talking about, that power electron device, it can handle the non-linear load at the PCC itself, so that the combination of this and this is appearing as a perfect linear device to a grid. Now you got my point. So he has rightly said that all the non-linear devices charging, all these are coming up, but at the same time your power electron device is also available there. If you combine this one and this one, combination of both can appear as a linear load. So only the exchange of active power, means if you are generating more than the load demand, only the active power is going to be injected. If you are generating less than the load demand, only the active power is being drawn from the grid. There is no exchange of reactive and harmonics at that point of common coupling. That means you have solved your problem and you solve the grid problem also. So that kind of concept we have inbuilt inside this system. So this was a case of three-phase system where three-phase system was there and three-phase four-wire system. So you can say that you can have that power injection, generated active power injection, load harmonic compensation, load unbalanced compensation, and load reactive power compensation. All these things are taking place at this side only, and nothing is going to flow toward the grid side. Only the exchange of active power, because load harmonic and load reactive power has been already supplied from the this side, and whatever active power in deficit it is generating, it has to be plus minus from the grid side only. Mismatch has to be supplied from the grid side. It can be positive active or it can be. So this is the way we introduce the concept, and this is the, so RE is interfacing without compulsion. If you can imagine without compulsion, you see the grid is going to be more polluted. Why? Because if you are injecting only the active power from the renewable and the load is consuming active as well as harmonic as well as reactive power. So suppose you made the active power demand from the your solar power plant only. So what will happen? You are taking your load, reactive load and harmonic demand from the grid side. So that means you are polluting the grid. So if I can draw the algorithm where I can supply the local harmonics as well as the reactive power, then no harmonics or reactive power are going to supply to the grid side. So only the active power balance are going to be exchanged. So this is the concept, that only the active power flow will take place and reactive power will be taken care by this device only. So this is the case like this. So these are the non-linear load. This is a grid tied inverter, and the combination of this or the switching of these devices has been done in such a way that the combination of both appears to be as a balanced active power load. Battery DC link capacitor and connected with the generation. Battery नहीं रहेगा ना, generation is there ना, that is playing as a natural inertia. So what the natural inertia concept which people are trying right now, implement that natural inertia concept in 15 years back, 15-16 years back, because the amount of energy which is being generated here, it can be injected into the grid as per my wish, as per my requirement. And my requirement is that I have to operate always at unity power factor without polluting the grid. Whatever I am doing on my load side, it is okay, but I should not pollute the grid. So that is the requirement, and I can show you there also. Active power profile, reactive power profile. You see all these curves, whatever exchange is happening, the load is almost fixed, generation is variable, but the grid is not supplying any reactive power. Grid is not supplying any reactive power because the reactive power is being supplied from the load, generator side, solar power or wind turbine side. Similarly, you can see here also. This is non-linear load, and you see this is my generation. The current becoming more polluted if I am not compensating. This is without compensation. You are having grid voltage, you are having grid current, you are having non-linear load current, and you are having perfect sinusoidal unity power factor generation. Means when you are generating at unity power factor only, then what will happen? Only active power will be generated, but load at point of common coupling is non-linear, so the grid is becoming more polluted. Now at this harmonic level has been increased and further. So depending on the amount of active power I am generating, closely proportional to that my harmonics are going to be introduced in the system. But in this case, if I am not only injecting the active power but load, harmonics and current reactive power demand also, then my grid current is always unity power factor and sinusoidal, no neutral current. Similarly, you can see these are the experimental studies. This is the grid side current and all these things. If I am generating only reactive power, the grid is going to be more polluted because the current is becoming more non-linear. This is grid voltage, this is grid current, and this is load current, and this is injected current from the renewable. So if I am injecting the current just exactly or equal to this minus this, only the harmonic part is being drawn from the grid. So it is creating more pollution. But if I do something like that, so this is without compensation in all the three phases, and this is the case where you see grid is always, if I am generating exactly equal to my load demand, there is no current is being injected or taken from the grid, so it is becoming almost pollution free. And further, if I am generating more than the load, I am injecting only the active current. Injection means it is anti-parallel, na? Opposition means it is injecting. If it is out of position like that, in phase, it is out of phase. Here I am generating less. So some part I am drawing from here and some part I am taking here, so to meet my load demand. Third one is the load curve. So you can see that experimentally we have proven that if we can control this generating current or grid side inverter current, then the harmonic inside the grid can be minimized. But in this case, you are introducing the harmonics. So this is the beauty of the system. So similarly, this is a 3-phase 4-wire system. We have introduced all these concepts, all dynamic condition under from very small generation to high generation and then more generation. You can see the switchover. The grid current is becoming almost zero when you are generating equal to the load current, and then same. So under dynamic condition, these results have been produced, or you can see here this is the load current generation, this is the load current, and this is a perfectly sinusoidal grid current. So this is the 3-phase 4-wire system where the compensation unbalance is also taken care and neutral current become zero. The unbalanced current is also going to supply from the inverter side, from this fourth leg, this one. The fourth leg has been introduced for the neutral leg. So that neutral current can also be. So if neutral current is 0 from the grid side, it means the grid is perfectly balanced. So the load can be unbalanced, generation can be balanced, but the load is, the grid is always going to be no. I am talking about distribution generation, no, at DG level. When the system is going to be installed at DG level, at distribution level you are having neutral.
कह रहे थे कि एक्टिव पावर या तो ग्रिड में जाती है अगर यहाँ से ज्यादा हो गई डीसी से, अगर कम हुई तो हम ड्रॉ करते हैं, तो उसका कोई इफेक्ट नहीं होता ग्रिड पे जब हम उसको दे रहे हैं.
हम ये मानते हैं कि वी आर कंसिडरिंग आवर सिस्टम ए वेरी स्मॉल वन एंड ग्रिड इज जस्ट लाइक ओशन. So small exchange of active power, it has to be taken care by the grid itself. Within 5% का fluctuation में आ जाएगा. If it is going to more, if all the such devices are going to behave in that way, then definitely some energy storage devices are there, but they will only exchange the active power. Reactive and harmonics you have controlled at the generation itself, generating end itself. So exchange of active power can be managed. But for reactive power, you have to install capacitor bank or reactor. That can be avoided. The crux of is that way.
सर अगर इंटीग्रेटेड कॉम्प्लेक्स सिस्टम जैसे दिल्ली है, दिल्ली का अपना ट्रांसमिशन डिस्ट्रीब्यूशन नेटवर्क है, जनरेशन नेटवर्क है. इंटीग्रेटेड सिस्टम है जिसमें केबल भी आ रही है, मेट्रो भी आ रही है, यूटिलिटीज भी आ रही है, रेसिडेंशियल नोड्स भी आ रहे हैं, सारे आ रहे हैं. इसमें ईवी और रिन्यूएबल की भी लोड आ रहे हैं. इंक्रीमेंटल है, नेसेंट स्टेज में, बट इंक्रीमेंटल फॉर्म में आ रहे हैं. एज अ पावर सिस्टम प्लान हम कैसे इसे आइडेंटिफाई करें कि ये जो पर्टिकुलर प्रॉब्लम हमारे सिस्टम में आ रही है ये रिन्यूएबल एनर्जी की वजह से आ रही है या फिर हमारे अदर जो एलिमेंट्स हैं जैसे केबल है या लोड डिवाइसेस हैं उनकी वजह से. टेंजिबल डिफरेंस.
You are from Delhi transfer. So I am giving you answer of your question. Suppose I am going to install 1 megawatt solar power plant at my location. For that I have to take permission.
Yes.
I will take a permission from the DISCOM. Why that permission required? Because DISCOM knows how much active power injection I can handle, and they are having a limited quota also. Because most of the power that transformer all of these are designed to have 20 to 25% overloading capacity, and in order to have future forecasting, considering future forecasting, they are always installed 50 to 70% higher capacity. So that capacity right now being exploited right now, but in future you have to definitely plan different matters also, because if you are installing a renewable power, you cannot inject into the system until unless you don't have vision for evacuating it. Similarly, if you have a utility scale charge station, you have permission also for that. Standards are already given. Similarly, metro are also facing problem. If they are going to inject some harmonics, they have to pay heavy penalty. That's why they are coming. So provisions are already there, but till now not means, because till now the transfer size capability and the transmission line network capability that has not been fully exploited. During peak load also, when we are having 7,500 megawatt load demand in Delhi, we have not heard of any breaking of the tripping of the line. Our system is already existing, but in future.
My point is, at present is the difference.
Yeah.